Hello, geometry students. We are going to take some notes today. Today, our notes are going to be about the idea of triangle congruence, proofs. So using those theorems that we learned about earlier this week to prove that triangles are congruent. So there are a few examples that we are going to talk through, so make sure that you are filling out your notes organizer as you watch this video. The first diagram that we are given is provided to us right here on the side. Our job is to notice what is marked in this diagram and write those facts down as our evidence at the top of this flowchart, and then use those three facts to draw a conclusion about these two triangles. Likely, we will be saying that these triangles are congruent. We need to use one of our big 5 theorems to prove that. So, I notice a few different markings on these triangles. The first one that I see right off the bat is this marking of a dash with the number 12 on a side length. So I'm going to write about that fact first. So I know that that dash marking means congruent, or the fact that those side lengths are both 12 means that those sides are congruent. So I'm going to say that AC, which is a line segment or a side length, is congruent to XZ, which is also a line segment, by the markings on the diagram. Next, I'm going to look and find a second fact to be able to write about. I see a singular arc, or an arc with a singular dash on 2 of the angles, and I know that that symbol also means that those pieces are congruent, so I can say that angle A is congruent to angle X by markings. And finally, I see one more set of arc markings, this time with 2 dashes inside of it. So I can also say that angle B is congruent to angle Y by the markings. So all I did was take the markings that I was seeing on this diagram, turn them into factual statements, and now this is enough information to try to prove that these triangles are congruent. We need to think about which theorem we should use. If I am reading around this triangle or thinking about what I see, I have 2 angles that are marked as congruent and 1 side that is marked as congruent. So this could either be angle side angle or angle angle side congruence. I need to do a little bit more looking at this diagram to see. I have an angle, another angle, and then a side that is not between those 2 angles. AB is not the side length that is marked as congruent. A side length that is disconnected from those 2 angles is the one that is marked as congruent. Therefore, I have angle, then an angle, then a side. So I have angle, angle, side congruence that I'm going to use as my reason. Now, what is it that I'm stating? I have to talk about the fact that these triangles are congruent. So I'm going to write a triangle congruence statement. So I'm going to say triangle ABC is congruent to triangle. And now I need to be careful about the order. Angle A and angle X have that singular dash marking. So that is an angle that is corresponding. Angle B and Y go together. So finally, Z and C will go together. So I can say that triangle ABC is congruent to triangle XYZ by angle, angle, side congruence. And now we've just written a proof, like we've been practicing, specifically for our triangles using the theorems that we've been learning about. So let's try another one. This time, I see 2 triangles, and I see some maybe slightly different markings. So let's see what we can figure out here. I notice a really important marking in the corner of 2 of those triangles. I notice that there is a right angle at angle K and angle T. By those markings. Another way to say this is angle or triangle, I guess I should say YKE is a right triangle. And same could be said for triangle TRU. So I could state the fact as them being right triangles. I could state the fact that they are 90-degree angles. Either way, I'm trying to get at the idea of I'm looking at 90 degrees. I'm looking at a right triangle. So however we want to state the fact, either as I'm seeing 90 degrees or I'm seeing right triangles by the given markings is fine. Then I also see a side length that has a single dash mark that is a length of 5. So I can say that line segment YE is congruent to line segment UR by the markings. And finally, I see one more set of dashes or congruent sides. So I will say that line segment TU is congruent to line segment KE. Also by the markings. So now I need to draw a conclusion that these triangles are congruent. So we are going to write out that congruent statement. So now we are going to say that triangle, let's start at KEY, is congruent to triangle. Okay, now I need to be careful. Angle K is the 90-degree angle. Sorry about the bell. Angle K is the 90-degree angle, which means angle T is the matching also 90-degree angle on the other triangle. So K and T go together. Then from K, I went over to E. So KE makes that double-dashed blue marking. So from T, I need to go over to U to also make that double-dashed blue marking. So I'm going to go T, then U, which then means the third letter has to be R, but we also could have figured that out because from where we were at E in the middle, E to Y makes that orange marking, so U to R also makes that orange marking. So these are the triangles that are congruent. Now, why are they congruent? What is the reason we need to state the theorem? So these are congruent by... In this case, I am looking at a right triangle where I know that YE and UR are congruent, that's the hypotenuse, and I know that KE and TU are congruent, which is a leg. So these are congruent triangles by the hypotenuse leg congruence theorem. In this next diagram, there's going to be a little bit more that we need to do. The reason being is that these triangles are now stuck together. They are stuck together. So we are going to look at a new property in order to help us solve this kind of triangle diagram. Now, this property on its own seems like a silly fact to say, but it counts as our one of our 3 pieces of evidence to be able to fill in our flowchart. The property is called the reflexive property. The reflexive property. Now that's reflexive with an X, not reflective with a CT in that case. And what it says is you're stating that something is congruent to itself. Whoops, stating. Something is congruent to itself. So this could either be sides or angles, usually, we would use. So in this diagram, a side that we might want to say is congruent to itself would be that side that these two triangles are sharing, that side AC. So in this example, I can say that side AC is congruent to side length AC by the reflexive property. Now that's helpful to say because now that gives me one of my three facts. So that's like putting a marking there of like, okay, a third side, right? So then I also still get my regular two sides that are marked on this diagram. So in this example, AD and AB are congruent to each other by the markings. And BC and CD are congruent to each other also by the markings that were given. So now in this diagram, I have said two sides are congruent, or a set of sides are congruent, a set of sides are congruent, and a set of sides are congruent. So all three sides of these two triangles are congruent to one another. Therefore, these two triangles are congruent to one another. So we can say triangle, I'm going to say ABC to represent the top one, is congruent to triangle. Now A still goes to A, then B in this case is at this top point off of A, it's following the blue marking, so off of A following the blue marking would be then D, and then over to C. And these are congruent by side congruence. All three sides are congruent. Now you will see a little bit more notes at the bottom down here. We will fill that out halfway through class today when we are working on the Desmos activity. You will see another video. So leave this part of your notes blank for now. We will fill this in later. So for now, that's it.